Hello, everyone, and welcome to the Future Space. I'm your host, Daniel Fox. Our guest today is really special, while considering everything that's been going on lately, is Dr. Amber Straughn. Amber is the Deputy Project Scientist for the James Webb Space Telescope. Amber, welcome to the Future of Space.
Thank you. Thanks for having me.
Now, obviously, there's a lot going on in your world, but before we get to the telescope and all the amazing discoveries, could you share with us 3 words that for you capture the essence of space?
I would say awe-inspiring. Count that as one. Captivating and beautiful.
Have you always been, you've been working for NASA for a long time. Have you always been attracted by space and the stars, even as a young Amber?
Yeah, for sure. I grew up in rural Arkansas, total middle of nowhere on a tiny little farm, far away from any city lights. And I got captivated by the sky from the time I was a really, really young kid. Like before I even started school, I was, always kind of looking up at the sky.
Do you think that I've been doing solo wilderness expeditions for a long time, and I've written about nature. And for me, there's an element of the experience, this viscerality, this physicality of experiencing nature, and also the night sky saturated with stars. Like you can't replicate, because now we live in the world of VR and simulations, and you can replicate all these environments, but it doesn't replace this visceral, the physicality of the experience. Would you agree with that?
Yeah, totally, completely agree. And I being outdoors, hiking, that sort of thing is really like how I kind of rejuvenate myself. And so same sort of thing. But yeah, the experience of a night sky full of stars is something that, yeah, you can't replicate in VR. It's so, anyone who's experienced it knows it's hard to put into words what that, what it is. And for someone like me, who has sort of made this into my life's passion and my career, it really is something unique.
There's a humility in the process. I think there's a certain vulnerability because you feel how little you are, which you don't really experience in the simulation because it's a technology that you created, and there's something missing. But when you're out there in nature and you face these forces that are so much bigger than you, you're standing under this night sky saturated with stars, and you really feel the smallness of our planet and the humongous size of the universe. Did you feel that humility, that vulnerability?
For sure. Yeah. Both in the experience of, seeing a sky full of stars, and also through the experience of, seeing these images come back from space telescopes, most recently the new one. But yeah, absolutely. And I think humility is a feeling that often comes up. I hear people talk about that. And just the fact that, I don't know, astronomy for me, it kind of takes you outside yourself a little bit. It causes you to ask big questions. That's one of the things I love most about astronomy. The questions that it prompts are more than just sort of arcane science questions. They're questions that really get to the heart of what it means to be human. Where do we come from and how do we get here? And are we alone? Those are questions that we all have, sort of coming from different ways, different angles, but they're very sort of deep human questions.
Now, talking about human questions, what would you think is, there's a lot of science about space, there's a lot of technology about space, but beyond that, what would you say is the human story of going to space?
I think the human story of going to space is, it gets to also a very human, visceral sort of drive that we have to explore, to sort of break out of our own little bubbles, and the bubble of the earth is sort of the ultimate one that we're all in. And so I do think it's about this pushing boundaries, getting outside what we're used to, and really that sort of that fundamental part of us that wants to explore.
I think it's hard for people. I mean, back in the days when it was just about crossing the mountain or going over the river or getting on the ocean, physically, even though there was a lot of pushback, even people, the European migration, a lot of people said, I mean, why would you go and risk everything and start a new life when there are problems in Europe to fix? I mean, we understand even, I mean, we hear often the same kind of conversation within families when one of the children decide to leave the village or the town and go and visit the big city. Often some of the people behind will have, it's like, well, you left us, you decide to go and fly. But I think it's what is harder for people now is just because of really the physicality of what that step is. It's a planet now that we're about to move beyond. And as if we continue with that example of the family, no child leaves their family to leave their parents. I mean, depending of their family, but no, it's the family will elevate in the same, it's you broaden, you increase the wealth of all the members of the family, and going to space will definitely do that. It's not at the expense of the earth, but really for the benefit of the earth and for the future. Do you feel that slowly the narrative of that conversation is changing from where it started some couple of years ago, where there was such a pushback?
I think it is changing a little bit, maybe a little bit slower than some of us would like, but I get it, I guess. I mean, I had members of my own family in Arkansas growing up, and I'm a first gen college student. And I definitely had members of my own family, not my immediate family, but extended family, who were not happy with my decision, even to go, a couple hours away to college. And then for grad school, I moved all the way across the country. And so I definitely experienced that myself, and I sort of understand, where that's coming from. But at the same time, there is no doubt that if we as a species are going to survive into the future, we have to. The Earth is not going to be around in 5 billion years, and we have to leave the planet if we're going to survive as a species far, 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 far into the future. It does seem like people are coming around a little bit more. At least I hope so. I mean, space travel is amazing, and I think it does still captivate the public, which is a good thing, because it's going to take, public funding. It's going to take not just our country, but countries around the world to, I believe, to come together and really make us a multiplanetary species. It's going to take all of us. And so I think we're moving in that direction, and I sure hope so.
Yeah, teamwork is definitely a theme that's coming back when it comes to space. It's not like you can just get your backpack and go into the wilderness and build your own little cabin, and like there's nothing about space that you can do by yourself. It forces the cooperation, and James Webb Telescope is definitely an example of that. But just to wrap up a little bit about this human drive of exploring. No one in North America exists. I mean, everybody that exists in North America exists because of someone who left their home at some point. And if we want to go back, you can go back as far as to the beginning of our evolution. Everybody has been able to exist because at some point there's been, an expansion of our territory. And I think that's one of the successes of the human species, is that we've been able to take the kind of organized random chaos of nature and go beyond that, right? We're born in one place, but we go beyond. We're not limited geographically by this place. We're born naked and without a roof, and yet we put clothes. We invented the clothes and built a roof upon our heads. And I think that when we were nomadic, we were at the mercy of the changes around us, And then when we became sedentary, then we started to build a certain stability and predictability, and then you're able to build on top of it. And we know, the famous saying of, the dinosaurs disappeared because they didn't have a space program, is at one point we know that the planet will have bigger challenges that are beyond our control, and then the survival of our species will depend on their capacity to go beyond. So I think that is the story that I think unites us all. And for me, there's one of the things that I keep in the back of my mind is I don't want to rob the future or the present of an entire generation of future people that would not have a life of discovery because we decided to step back and not go over there. Because if that was the case, I would not be here. You would not be there either. So I think we owe it to the people of the future. I mean, is that something that crosses your mind?
Yeah, of course, absolutely. It's and you can also think of it more also in terms sort of closer to home, closer to the present moment, with our challenges we have for climate change, those sorts of things. But absolutely, for the far future, yeah, our species depends on it for sure.
Now let's go into the James Webb. Obviously, you've been working on that for a long time, and a lot of media coverage and the focus has been on the photos that we got. But before we go there, I want to focus on the fundamental accomplishment of what this project on the human level. We're talking about 15 countries, I think 250 something plus companies, different languages, different cultures, over decades. So what is for you, I mean, the human story of the James Webb Telescope?
I really think the human story is that when we come together as humans, as people, we can do things that are really, really, really hard to achieve a good common end. And I think this telescope is the perfect, example of doing that. Seen on the videos, right? This telescope is enormous. It's 4 stories tall. It's got this sunshade that's the size of a tennis court. We had to fold it up to put it in the rocket. It had to unfold in space. We had never done anything like this before. We had to invent 10 brand new technologies just to get started on the telescope, things that didn't exist. We'd never deployed optics like this in space before. It was so many things about this telescope were really pushing the edge of what was possible in an engineering sense, like pushing the edge and even going beyond sometimes, because we had a lot of issues in trying to get this telescope ready to launch, and we had to stop and back up and fix things, and we had to test and retest and test again because we know that we couldn't go fix it if anything goes wrong. And so it's a huge, monumental engineering challenge to get this telescope into space. It's also the most expensive science mission that NASA has ever undertaken. It comes in at about $10 billion, spread out over, the whole couple of decades that we've been working on it. So you have the most expensive science mission NASA's ever launched, incredibly complex, never been done before, and we can't go fix it if something goes wrong. And so you put those things together and you can see how much was riding on this telescope and on getting it right. And I think the fact that we could come together as 3 different separate agencies, it was NASA, the European Space Agency, and the Canadian Space Agency, all the countries that are involved in the European consortium. And really, beyond that, a world full of astronomers whose lives weren't depend on this telescope. So it really it was a worldwide effort, and it is, I believe, going to be a benefit to the world as we start learning things from this telescope.
Was it a little bit outside of the typical NASA culture of risking so much? I mean, there was so many single failure points on the James Webb, like putting so much investment and time on, and on these, and so many items had to go perfectly, and and it worked. I mean, I remember watching it; it was absolutely incredible, and you just I get goosebumps just remembering the December 25th. I remember, it was the perfect Christmas gift. But watching this product of engineering, a pure, I mean, the human invention, and everything had to work, and not to the inch or to the centimeter, but to the millimeter, and to this hypothetical place, because we've never been to it. We know of the L2 on paper, but it's not like, okay, there's already someone waiting over there to receive it. We're sending all that over there. Is that all that kind of a little bit outside of the NASA culture, taking that much risk?
Well, yeah, risk is definitely something that NASA thinks a lot about. And yeah, I've heard people say NASA's very risk averse, which is true to a large extent. And so, yeah, taking on this challenging of a project, like you said, hundreds of single point failures, so that if this one little thing goes wrong, we don't have a telescope. That's intense. And I believe it did sort of at times like stretch the sort of culture at NASA in terms of doing what we had to do to retire all the risks that we could, right? You do everything you can to make sure that everything works the way it's supposed to. Honestly, at the end of the day, that probably added some time onto our schedule. Whereas I don't know, another organization might have accepted more of those risks. We were very, very careful to make sure that we reduced the risk as much as we could, so that we had a successful mission. And so it's always sort of a give and take, a balance of managing the risks, with the right balance, so that you don't add too much time and too much money and to the schedule, but making sure you're comfortable enough with where things sit that it's going to work. And of course, that was all handled on more on the management side and on the engineering side than the science side. But yeah, it's been interesting to be a part of this mission and sort of see those conversations happening. Really, really interesting human story on that level as well.
I mean, for something to be the need to be so precise, the calibration of those mirrors had to be done in a millimeter, and it's micro movements. And to think that this telescope was on the top of a rocket vibrating, and the G-force and released, and it's just everything has to come exactly perfectly. It's astounding how it all worked without any big issues. But it's also to see the accomplishment reminds us of how we're able to achieve the impossible when we put our minds to it. And I think, as you said, that's the human story. Now, Amber, I obviously, some of the photos came out, and I wrote a post on LinkedIn about how the one, and I can't remember exactly the name, but the one that has a clear demarcation, some people have compared it to mountains. But my belief is, I don't believe that the nature of the universe is different than the nature on Earth. Life in the big scheme doesn't try to reinvent the wheel. It has, whatever principles and dynamics apply to us, they also apply at the micro level and also the macro level. And when we discovered the DNA, decoded the DNA, we identified what we didn't know as junk DNA. Now we understand that junk DNA doesn't exist. There's a reason for all this. When we look up to the sky, there's a lot of stuff, dark matter that we don't see and we don't understand. But do you believe that it's just a question is because we don't see it, but it's filled with a lot more that we just don't know? And James Webb is going to give us, some tools of discovering the invisible and making us understand that there's just so much more that we haven't just discovered yet.
Yeah, for sure. And for me as a scientist, I believe that's the most exciting prospect of this telescope is, we have all these very specific questions that we're going to set out to answer, that we sort of built the telescope to answer. And I think we'll answer those, and that'll be great, and it will add to astronomy. But this idea that there are things like out in the universe that are going to surprise us that we didn't expect at all. This idea that there are answers to questions we haven't thought to ask yet. Like, that's the fun part. That's the most exciting thing. Like, what is the universe going to throw at us that's going to completely, just completely knock us back and make us think, what is going on here? We have to rethink how we understand the universe. And that happens. That's happened in the past. And I think it's going to happen now. And you can't even predict what it's going to be, but it's exciting.
So what is the timeline of James Webb? I mean, obviously the first photos came out. Is your team gonna deliver regular photos, or there are going to be these public, not dump, but the photos released to the public? So what's the timeline and the plan?
The timeline is now. So a lot of the data from the first year of observations with the telescope, a lot of that data is public immediately. And that's so that the astronomers can get their hands on the data and start really figuring out, how the data works, how to optimize future observations, those sort of things. And a lot of that data has already been taken. The commissioning, the 6-month commissioning period of getting the telescope ready to work, it went so well. Again, all of us are kind of like, we can't believe how smoothly everything has gone, knock on wood. But it went so well that we actually started taking real science observations in the last couple of weeks of commissioning while we were taking these first public images. And so there's already data out there that's already, been released to the public. There's a really cool image of Jupiter that came out, I think, the day after we released the first images. There's this gorgeous new image of a galaxy that's out there in the public. And so since a lot of the data are public, a lot of it is already coming out. But the team at NASA that sort of puts together the sort of more formalized scientific press releases about the data, that stuff will come soon, within a couple of weeks, I would imagine, because astronomers are going to start publishing as soon as they can. And of course, the publication process will take weeks, but it's gonna start happening really fast.
Who's managing all this, the priorities? I mean, I'm pretty sure that there's a long line of people at the door knocking. It's like, can we do this? Can we do that? Is there one person like having to, with the list and just said yes and no? Is there one person like that?
There's not one person. There's a team of people. So the way it works to decide what the telescope looks at, it's the same process that we use with Hubble. So basically every year, astronomers from around the world get together, usually in teams, and write up their best ideas, their proposals for where to point the telescope, and try to explain why their idea is the best and why that science will be the most impactful. And so astronomers submit their proposals once a year, and then over the next few months, another group of astronomers reviews the proposals and ranks them, and the highest ranked ones end up getting selected. All of this is dual anonymous. It's anonymous from both sides, to try to decrease the bias and all that kind of stuff. So that's the way it works. The best ideas float to the top and get observed. And the great thing about the data from these big telescopes is that sometimes there's a proprietary period. So the lead scientist will get 12 months with their data where they can do all they can. But after that, the data is public. All of the data that JWST takes will eventually be public. And that's for the greater good of astronomy and of science. I did most of my dissertation research on archival data from Hubble that was taken, a few years back and was in the archive. And most of the science that comes out of these telescopes comes from that kind of archival data. So I think that's a really good sort of baseline policy that NASA's adopted with these big telescopes, is that the data is for everybody.
It's incredible. I was watching, you were recently on I think it was a Bloomberg piece. It was a 30-minute explanation in depth with James Webb and the telescope. And then there's a special animation that shows the light coming in and going in the spectra. And just watching this piece of engineering and being reminded that people come up with those ideas and now it's something, and the that connected to these planets that we can look and we can decode the air around them, or the gases around them, depending of that spectra reading, is just absolutely mind blowing in so many ways. I mean, do you still get excited of that kind of simplicity? Because I think for the rest of us, we're just, it's so mind blowing.
Yeah, absolutely. I mean, it's incredible. It's incredible what we've been able to do, with like all the thanks in the world to the engineers that built this incredible machine. I mean, the engineering, again, as a scientist, the engineering side of it just blows me away. But yeah, the fact that we can build this machine that has a mirror, that if you stretch the mirror out to be the size of the continental US, the biggest bump would be an inch or so. Like, the mirror is so smooth. The fact that we can even make a mirror that smooth is remarkable. And then fold the whole thing up and, like you said, shake it. And then it unfolds, and now we're getting back these images from, yeah, looking at the atmospheres of planets orbiting other stars in such precise detail that we're able to tell what's in those atmospheres. And then looking all the way back to see the first epoch of galaxies born after the Big Bang. We're talking about looking back in time over 13 billion years. That light's been traveling for 13 billion years, and then it hits our telescope. And from that, we're able to learn what these distant galaxies are like. So, yeah, even as an astronomer that sort of thinks about these things all the time, of course, it's mind blowing. It's incredible. It's amazing.
I think that back in the in 1700s and 1900s, we were like amazed at what humans could achieve physically. I mean, I'm always reminded of the explorers of Antarctica or the Arctic that would go and risk their lives to measure the weather, just so that they could record, oh, today was 40 degrees, and then they would come back with those stories of accomplishments, of resilience, of going beyond the limits. But now the same stories are applied to our capacity. It's not the human cost. It's not the human cost of exploration. It's not the resiliency, but it's your capacity to engineer the impossible and find these solutions that are just absolutely go beyond our understanding, our current understanding. And then we look in the future, and we can only imagine of what we're going to be able to accomplish so that we can continue pushing those limits of curiosity and knowledge. Amber, I have a question for you. In 2020, there was a big 2021. Sorry, there was a big tipping point in our awareness of the space economy, and one of the things that I wrote was the number of views that NASA got on their YouTube channel for the landing of Mars, the rover. There was 22 million plus just on YouTube, NASA. And I compared it to the first episode of Friends in 1994 with all the marketing had gotten 22 million. And my point was to illustrate how now there's been a tipping point into the place of NASA. I know that in my social media, the pictures of James Webb have been all over my feed and everywhere, but I also live like in a little bubble of space and nature. But outside of those bubbles, have you been aware of the media impact and how broad the reach has been since the James Webb release of photos?
Well, I'm also in a little bit of a bubble, admittedly, but I did see a report. Part of our communications team compiled a PDF showing the number of front page newspapers across the world that had our images on the front page, and it was well over 100. I'd have to go look up the actual number, but it was amazing to see it, not just in the U.S. but around the world, about how it made the news media around the world. I think they said over 6,000 individual outlets actually picked up the story, and some huge number had it on the front page. It was probably way more than 100. I just can't remember the number off the top of my head. But I do, I don't know for sure, because again, I am in a little bit of a space bubble myself. But my sense is that it has reached a bigger audience than just the space nerds. I have my own friends on Facebook and so forth that aren't in the bubble, that have been posting about it, and have seen the images. So I think my sense is that it has sort of expanded beyond what typical space news media would pick up, and even national level media. I really think people are drawing a parallel between this telescope and Hubble. And I think Hubble is this perfect example of a telescope that has really made it into pop culture. You see Hubble images everywhere. Hubble images were on The Simpsons and in rock music videos and on the side of U-Haul trucks. And, they're ubiquitous. People love Hubble. And I think this telescope, JWST, it's going to be 100 times more powerful than Hubble. And I think the images have the same appeal, that same sort of visceral human appeal. And so I think that it's going to be the same sort of thing.
Because I think it's the most important, to be able to go beyond these boundaries of communication. Where, I mean, yes, within our community, it's great, but it's the people who usually don't connect but where the effort is really needed to connect and have it resonate with them. It's the same thing with environment. It's something with, same thing with anyone, because it's often we get trapped into what resonates with us, whether it's the science aspect but for other people, the lack of resonance, of viscerality, it makes them harder for them to go and say, well, okay, I can see the big deal. So there has to be a shift in that storytelling so that, it goes beyond these boundaries. And I think that lately there's been more effort in making sure that the non-space people also feel connected. And, we saw that with Blue Origin when they go up, they have people. We had Michael, the football guy, the football, which is like the biggest sport in the US now, and on a Today show. Now suddenly there's someone that people can relate that has nothing to do with science. So it's, I believe, I would assume that there's a really dedicated effort at NASA to connect with the people that are not necessarily space people, correct?
Absolutely, yeah. Our communications team at NASA, which is broad and spans a bunch of different centers, and I'm sort of a little part of that from the science side. There is definitely a real intentionality about making sure that these images and the science that goes along with them are really accessible to the public, and to all parts of the public. There's a lot of, just an example, also a lot of effort that goes into things like alt text, so that people that can't see get a description of what the images are like, and those sorts of things. So there is a big emphasis at NASA to make sure that what we're doing is accessible to the public. And it's one of the reasons I do a fair amount of sort of public speaking and outreach types of things. I'm a government employee. Taxpayers pay my salary. And I think it's so important for these government funded projects to make sure that the public knows what they're getting. I take that very seriously. And I think NASA as a whole does as well.
Now, the launch went absolutely flawless. And apparently there was even so much fuel saved up that they boost up the life expectancy of the telescope. Originally, I think it was 10 years, and now we're talking about 20 years. Is that correct?
Yeah. Right. Right. Yeah. I mean, the launch was just like as perfect as it could be. And, we were all watching obviously it was watching the launch when it happened. And even the fact that we saw the solar array deploy, it deployed sooner than any of us thought. In fact, there was a little bit of talk like, oh my gosh, is something wrong? But the fact is that the launch was so efficient, so perfect that process was automated. And so once it achieved, a certain milestone, the solar array deployed. And it was so close to perfect that it deployed sooner than we expected. And so, yeah, it was a beautiful, beautiful launch. And that means we're estimating about 20 years of lifetime for the telescope, which is incredible, based on fuel.
Well, if you had any projects of retiring in 10 years, now you're going to have to wait for 20 years before you move on to something else. So you better cancel all your plans because, your agenda has been changed now.
Exactly. Astronomers are always wanting data, so we will take as much data as we can get.
No, it's so the same thing happened with the Mars rover Perseverance and Ingenuity. There's these milestones that NASA sets for itself, and then everything happens really well, and then it boosts the longevity. But there's a little part of me that feels like NASA is really putting the bar really low, so that if everything happens, then it makes them look like, oh look, we get that. It's because you've been successful at going beyond. I mean, these rovers have been on Mars for so much longer, and now the James Webb is. I mean, I know you can't tell us, but is the bar set at a really low risk level so that it's easier to go beyond the expectations? Is that a strategy maybe you can share with us?
So I often hear people say, sort of tongue in cheek, that NASA makes things look too easy. Like we shouldn't make things look so easy, but it's not easy. None of it is easy. And you and your viewers know that space is never easy. But in sort of the NASA speak, we set, mission requirements. Like, what do we have to do? How do we need to build this telescope to meet, this list of basic requirements? And we build the telescope to meet those requirements so that anything above and beyond that is just sort of bonus. It's extra. But yeah, that's how we operate. And we definitely don't set the bar low. I wouldn't say that. But it really is a matter of setting the requirements. And, I mean, come on, full honesty here. Before we launched this telescope, like we did everything we could in an engineering sense to make sure things would go right. And I had trust in the engineering. But look at this telescope. I mean, I was worried a little bit about the deployments. It's just there was so much riding on that telescope deploying, and so much to lose if anything went wrong. And so, it was like I'm still like pinching myself. Like everything went so well, and the images, the telescope is working better than we expected. The images are deeper than we expected. And so it's huge credit to the engineers and our engineering partners that built such an incredible machine.
Well, my hat to you and the team and everyone, because I think, we get goosebumps by looking at the photos. We get goosebumps by thinking of how it got there. We get goosebumps by just imagining the complexity and they work flawlessly. Like it's a big bag of goosebumps all over, and it never, it doesn't stop giving. Amber, I want to be mindful of your time. Before we go, what would be for a younger generation? Like for me, it's always really important. I'm old and in late 40s. My vices and patterns have been well established, but for the younger audience, it was really at the beginning of and looking at this new future, the world, and even if they're not within space, what would be your words of wisdom for them?
I would say, first of all, and most critically, is that nothing big and important like something like this is ever achieved alone. You need help. You need people around you that can support you. And I know I had, really critical people in my life early on and all through to the present day that have helped me. And asking for help is never a bad thing. And so I think that building up your support structure is super important. And that applies not only in academics, but in life in general. At the end of the day, we're people, we're social people, and we need, other people in order to function at our best. And so I think getting good mentors, good help along the way is really, really important.
I think it's definitely been a part of the narrative within the space community, which was different from the tech era of the 90s and 200s, where we saw technology to replace humanity, right? We saw life as like, oh, they're too complex, too hard. Let's find all these technologies that can take us out of the equation and make everything better. But in space, we understand that our humanity has a value and a place, and technology is there to support and complement. And it's more of a teamwork rather than one at the expense of the other. And that, for me, I really find that more refreshing, talking about technology like that, rather than saying, humans are a bad species, we need to take them out of the equation. Humans are not a bad species. It's just that life is messy. Evolution is complicated. Learning is complicated because you never know if it's going to be a mistake or an innovation. It's only the hindsight that gives you the capacity to look back and say, well, that was stupid. But in that moment, we're all trying to figure out how to move forward. You've lived with this family that has accomplished the impossible. So I can only imagine that you're hopeful about the future. Am I correct?
Absolutely. And, people have been asking me all week, like, how do you feel after seeing these images, And I guess my instinct is I feel joyful, I'm overcome with joy that this thing actually works and that we're getting back these beautiful images. But a close second is hopeful. I mean, it really does give me hope that we can do it. We can solve hard problems. And I feel like this, the release of these images, it was, I feel like we're in a tough time right now as humans in this country and around the world. There are a lot of not good things going on. And I feel like this was this little burst of light, burst of joy and of hope and of happiness. And I hope that the world, can take that as inspiration and as a sort of little nugget of hope that there is good in the world. There's immense beauty in the world, and that we can do hard things for a greater good.
There's a lot more beauty. There's a lot more people doing the right thing than there are ugly things or people doing the wrong thing. And that's the reason why we're about to be 8 billion, is because there's a lot more of that. We just don't hear about it all the time. And I often tell people that when right now we're in this period of transition. We've been in a relationship with ourselves or with the planet for a long time. We're talking about decades and centuries. And we know it's not working anymore. But this long, it's like when you're in a relationship, it's finished. It doesn't, you don't break it up really easily. It takes a long time, and the stability and the predictability of what is extremely powerful. But now we're in this transition of that relationship is ending. There's a lot of pain and suffering, and we've all fallen out of love, and we go through the spirits like, I will never love again. I will never get myself into this relationship again. But then 6 months, a year later, you look back and you realize, oh my God, why was I in that relationship for so long? Now I'm better. And I know that in years, not that it dismisses the challenges and what we're going through, but there will be a time in the future where we're going to look back and we're like, yes, we're so much better now. But it was a hard transition. And I think we have to remind ourselves of this is what makes us successful as a human species. Every time we've reached those point of having to reassess how to move forward, we figure it out, we move forward. But it's a messy process. Now, Amber, if people want to find out, you mentioned a little bit earlier how every year there are these projects that people can submit. Are there links like on the web that people can go and kind of sign up for a newsletter or social media?
Sure, yeah. So there's a few different places. One of the hubs is our NASA website, which is jwst.nasa.gov, James Webb Telescope, jwst.nasa.gov. And then on social media, we're at NASA Web, WEBB.
Well, we'll make sure that we add all the links in the description and also your LinkedIn profile if people want to connect with you. I know you yourself, you're on social media, so we'll make all that available to people. Just before we go, what is for you the biggest discovery that you hope and that you're going to see in the next 5 years?
Oh, it's so hard because there's so much on the horizon. I'm really interested to see what that first epoch of galaxies is like, because that's what got everything started. So that's my scientific answer. But maybe the higher level answer is I really am excited to see what the universe surprises us with, something that we have no idea what to even guess about.
The unexpected, when our boundaries and the knowledge will have to be reassessed and reframed and everything, and when we feel like, oh my God, oh, geez. Amber, thank you so very much for taking the time. I know you have a super busy schedule. Good luck to you and the team, and I look forward for a path across.
Great, thank you.